Hello, we want to move on to line integrals. And so we have our definition here, integral over CF of xy ds. So our interval is from A to B, and x is in terms of t and y is in terms of t. And our ds is defined this way, x prime of t then squared and then y prime of t squared. So we shall differentiate and then we square them right away. So let's move on to an example. Evaluate integral cx squared y ds. Great. And so we are going to take our time and then solve this, where c is determined by the parametric equations x equals 3 cos t, y equals 3 sine t. Now t is from 0 to pi on 2. And so we have our x squared y ds, and our interval is 0 to pi on 2. And so our x has been interpreted as 3 cos t. So in place of x, we put 3 cos t, we square it. And then our y is also giving us 3 sine t. Then our ds is the square root of our x prime of t squared and then y prime of t squared. So when we differentiate our x, ds will give us negative 3 sine t. So that's why I have our negative 3 sine t, and then we square it. Then for our y, when we differentiate our sine, we shall get also 3 cos t, then we square all of them. And so when we do that, this will give us 9 sine squared t, and then 9 cos squared t. And then we can bring the 9 out as 3. And so 3 times 3 will give us 9. And then here too, we shall get 3 squared, so 9. 9 times 9 will get 81. Now, sine squared theta plus cos squared theta is 1. So we shall get 1 for the whole of this. Then we come here, we have our cos squared t and then sine t. So we are going to use integration techniques to do the integration. Now that we have this product, this is raised to the power 1, this is 2. So we'll concentrate on this. So from integration techniques, we add 1 to this, we get 3, and then we divide by 3. And the answer will be negative for cos, it will be negative, then the sign goes. So we shall get negative 81 on 3 cos cubed t within this interval. Now, when we now do our substitution, cos 90 is 0, so the upper we have 0 minus over here, when putting 0, get 1, so cos 0 cubed is still 1. And so our negative 81 on 3 will come to minus minus, and then we get 27 because 81 over 3 will give us 27. So that does it for question 1. Let's look at question 2. Evaluate the line integral given this way along the curve C, whose parametric equations are x equals t squared, y equals t cubed, and then our t between 0 and 3 on 2 inclusive. So that does it for this. Now, let's look at the solution. So now our dx will be 2t, t, and then our dy will be 3t squared, t. From the question, we have our x, because that's we get 2t, dx is 2t dt, and then y, 3t squared dt. So that's why we have them here. So we go back to the question. Now, we know our x, we know our y. They were all given in the question. So x is t squared, y is t cubed. So we'll do the substitution. So we get t raised to the power 4, y becomes t raised to the power 6 because we have the value here. All right. And so that is very important. I need to put the 2 there. Let's put the 2 here. Great. Okay. So we have x squared, y squared, and so that satisfies everything. Okay, so x squared will give us t raised to the power 4, and then y squared will give us t raised to the power 6. From question, we have x being equal to t raised to the power 2, so x squared becomes t raised to the power 4, and then y, so this one 2, we get t cubed. When we square, we get our t raised to the power 6. All right. And then we have our dx. Dx is 2t dt. So we get 2t plus. When we come here, our 2 is there. Then we have our x and our y. Our x from the question, our x is t squared, then t cubed. So when we find their product, we shall get t raised to the power 5. And then our dy is 3t squared. So we put it there, and then our dt comes. So we just need to simplify what we have over here. And so we'll work on this, and then we actually expand and we move on. So this times that, we get t 2t raised to the power 5, and then we move on to this, and then we also get our value. So this will give us 2t raised to the power 7, and then we come here. So 2 times 3 will give us 6, then t raised to the power 5 times t squared will give us t raised to the power 7. And so remember, we already have this one over here. And so this is also 5. So 1 from 5 will give us 4. And so we simplify to this level. Now, at this point, all that we need to do is that we'll do the integration. And so when we take our time and do the integration, basically we add 1 and then we divide. We add 1 and then we divide. Then we slot in the values for 0. Everything goes to 0. And then we will be working with our pi on 2. And then that will give us 8505, then 512. Then when we compute, we get our value. So let me work on this one. This one is actually 3. There's a slip of this thing. So this one is 3. So go back. So this is 3. It's not 3 on 2. Good. So when we slot it in after the normal integration, as we always do, we add 1, we get 6. So 2 on 6, we add 1, we get 8. 4 on 8. So when we take our time and simplify and slot in the values, we shall get this because we've been doing most of this integration. All right, so that does it for this. Now let's look at these exercises. Evaluate the line integrals. So 1, we have this expression where our c is the curve x equals 3t, y equals t cubed, then t from 0 to 1 inclusive. And then we also have the second question, c, where we have the whole of this expression. C is the line segment from 0 to pi to 2 pi. Great, so that does it for the line integrals. Continue to solve more questions on line integrals. There are varieties of them. Try your hands on a lot of them until you get grounded in it. Thank you so very much for your time. Thank you for listening attentively and continue to practice. Mathematics is practice, 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 and observation, and you are good to go. Thank you so very much for your attention.